Hey guys, welcome back to Pre-algebra class, and thanks in advance for liking and subscribing. Ring the bell if you like what you see and you want notifications. Moving on today, we're going to lesson 2.42, and we're adding and subtracting fractions today, something that may be a little bit of a review for you guys, but once again, we have to consider how this process changes when there's negative numbers involved. So let's just go through the essentials of what adding and subtracting fractions does. Once again, the learning targets for Unit 2 are I can efficiently convert decimals and mixed numbers to improper fractions. We're dealing with the latter here, mixed numbers to impropers, even when they have negative signs. So make sure that you are considering how we did that the other day. I can add and subtract fractions and decimals and mixed numbers that are positive and negative. So that is where the focus is really going to be today. I can add and subtract positive and negative numbers. But from a conceptual standpoint, let's see what happens when you have to add 5/8 plus 1/4. So I'm going to make a model of this really quickly. All right, and very conveniently, 5/8 here. Split this into eighths. So this is 5/8 of a pizza. 2, 3, 4. 5/8 of a pizza plus 1/4 of a pizza. Plus 1/4. I don't know why it's always pizzas. You could just deal with shapes. So the problem with adding and subtracting these, if you haven't noticed that, okay, well, how much pizza is there? Well, it's not really clear at this point in time because the slices of the pizza are not the same size. They are not the same size. So what has to be considered is, okay, how could I possibly make pizza slices that are the same size so that I can quantify the sum of these two fractional parts? Well, I think you might have already some background knowledge, and we did this in the warm-up, hopefully, if this class is going the way that I thought it was supposed to go, that we are going to have to split up the quarter slices into half quarters. And what are half quarters? Well, half quarters are eighths. The fraction 1/4 is really the same size as, you guessed it, 2/8. So what we are considering when we do this is, okay, 1/4 is really the same size as 2/8. And now you can say that I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8 to be able to be quantified of how much pizza is being added. Is 7/8 of a pizza. So essentially, if you're a visual learner, this kind of makes sense, right? We've got two different pizzas. They're cut two different ways, and then we have to try to add up the fractional components, right? So to do so, what you need is a common sized slice. You need a common denominator, all right? What about modeling 3.5? Let's go to subtraction world. 3.5, take away 5/6, okay? So here is 1, 2, 3 and 1/2 slices, or I guess in this case hexagons. But let's go to pies or pizzas or something like that. I have 3.5 pizzas, but let's say my friend comes over and he eats 5/6 of a pizza. He's quite hungry that day. He eats 5/6 of a pizza. Well, the problem is that these are not yet cut into 6. So let's go ahead and do that, and let's see what I can come up with. Let's see what I can come up with in terms of the difference. Well, if I have to cut these into 6, I would have to make a cut here, make a cut here, make a cut there, make a cut here, make a cut there, make a cut there, make a cut here, make a cut there, make a cut there, and the same thing is going to happen even for the one that is not completely filled in. So there's 3.5, and I have to take away 5/6. Okay, well, let's go ahead and unhighlight. There's 1/6, 2/6, 3/6, 4/6, and then 5/6. So that means that this amount will be remaining right there. And how much pizza do we have now? Well, let's count it. I have 2 holes, and then it looks like 4 6 remaining. Or you could say that I have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 6 slices of pizza. But let's see how this works. Okay, let's see how this works when I find that common denominator. 3 and 1/2 is really 3 and 1/2 is 6 times 2 is, or sorry, 2 times 3 is 6 plus the extra 1 is 7/2. Take away 5 6, and once again I have to convert this to something with a common denominator, which in this case the lowest common denominator possible is 6. So I have 14 6 total. And if you didn't believe me, you could count all of those up. Excuse me, no, that's incorrect. Is it? Wait, no, 21. It is Tuesday morning, and we're making some mistakes here. That's okay. If I multiplied the bottom number by 3, which I had to do, I have to multiply the top number by 3 as well, which is 21 6. Take away 5 6. Okay? 21 6, take away 5 6 is going to leave me with 16 6, which does convert to exactly what we're seeing here. It converts to 2 and 4 6. And now that's great. We can see 2 and 4 6 being articulated there. But you might also be realizing that, this can actually convert to a simpler fractional part. Okay, this converts to 2/3. So if I break this shape up into thirds, okay, with this green line, if I break the shape up into thirds, I am taking up 2/3 of that fractional part. So 16 6 is equal to 2 and 2/3. This just kind of simplifies or reduces by a common factor there. So that's essentially what we're doing here. Just a couple things to be aware of when you're making equivalent fractions is anytime that you multiply the bottom number by a factor, you have to multiply that same number by a factor as well. Okay, let me pause the video and let's see if we come up with the same answer on 3/4 plus 1/6. All right, and we're back. And hopefully, I took the time to make a model of what was going on here. Hopefully we got the same answer. I got 11/12. 3/4 plus 1/6 at 6th, adding up to 11/12. So what happened here essentially is, okay, to make these slices the same size, I had to make a cut down the middle of my 1/6 and really make that 2/12. All right, 1/6 is equivalent to 2/12. And I had to make 2 cuts in each of my quarter slices, meaning them turning them into 12ths, right? I'm cutting my quarters 3 ways, and 1/3 of a quarter is a 12th. And let's count. I have 1 2 3 4 5 6 7 8 9 12ths. 3/4 is equal to 9 12ths. So essentially what I have here is 9 12ths plus 2 12ths is equal to the final sum, which is 11 12ths, not quite 1 whole. All right? And hopefully you got the same thing. Some people may have actually even split these pizzas up even further, and you might have just made 24ths, right? Which that would have taken a little more effort to draw out, but not too much more effort to do with arithmetic, okay? So the arithmetic rule, let's highlight it up. You must get a common denominator, make equivalent fractions with a common denominator, and then we're going to add or subtract only the numerator part. Okay, and then we're going to reduce that final answer, and that's going to make sense. So let's go back to that last example. Once I had 12ths, I had my slices of pizza. The 12ths denominator stayed the same. I added and subtracted only the fractional part on the top, only the numerator part, right? That denominator of 12 stayed the same even in my final answer. Okay, and you can see the slices of pizza are still in 12ths. So the rule is we get a common denominator and then we add or subtract only the numerators. So on this example, 3 and 8, the smallest common denominator I could come up with is 24, simply the product between the two of them. All right, so I'm going to make a common denominator, and let's see, well, if I have to multiply thirds times 8, I have to multiply its top times 8 as well. And I have that 2/3 is really 16 24ths. With the 5/8 component, if I have to multiply 8 times 3 to achieve 24, I have to multiply 5 times 3 on the top to achieve 24. And it's really And now it says this rule says I have 16/24 plus 15/24. I have 31/24. And that is a fine answer because 31 is a prime number. That's as reduced as it can be. You can leave your answer just like that. Also, if you wanted to make this a mixed number, 24 goes into 31 one time with a remainder of 7. It's 1 7/24. Okay, moving on. Now, here is where it turns into a little bit of pre-algebra. If you have negative 2/5 plus 7/9, now we're dealing with positive and negative fractions, right? So in this case, we're going to have a signs are different, take the difference scenario. But first, let's consider I can't add these before I make a common denominator. So let's go ahead and do that. Okay, once again, 5 and 9. 5 is a prime number. 9 only has the factors of 3 and 3. The first thing that they are going to have as a common denominator is 45, 45ths, okay? But recall, when I do that, this fraction was negative. So when I multiply it times 9 as well, as a pro tip, let's put that negative sign up in the numerator. That's not a rule that you're going to hear in any math book, textbook. You're going to read in any textbook. But this is a pro tip. That negative sign was out front. I am going to be adding and subtracting these numerators. So I have to consider this one to be a negative fraction. Okay, and I'm going to go ahead and make sure that I multiply 5 times 7 as well to make 35. Now I have negative 18/45 plus 35/45. Signs are different. That's right. Take the difference. Signs are different. Take the difference. In this particular case, I'm going to have to take 35 and subtract 18. 35 minus 18. And you might know what this is already. This is 17, right? And the answer will be positive in this case. The answer will be positive in this case because 35's absolute value is larger, okay? So negative 2/5 plus 7/9, I still, even when I'm dealing with positive and negative values, I'm still going to have to consider those integer rules that I had the other day. Pro tip, put the negative sign on top, okay? Forward, onward. All right, now what about with mixed numbers? So to turn mixed numbers into improper fractions that have the negative sign in the numerator, like this one, negative 2/5 plus 3/7, okay, we are going to have to put that negative sign in the numerator just like we did on the last one, since that is what we are going to be adding and subtracting. Okay, so if we have negative 2 and 2/5, that is the tricky part to consider. So from the other day, let's turn that into an improper fraction. Well, 2 times 5 is 10, plus the extra 2 is 12. But remember, this note says that take that negative sign and put it up in the numerator as well. So I have negative 12/5 plus 3/7. Okay? Well, great, except for the fact that these do not have a common denominator. I'm going to need to achieve that common denominator of 35. So this is going to be a 35ths plus a 35ths. And what did I multiply 5 by? What did I multiply 5 by to get the 35? I multiplied it by 7, so I'm also going to have to multiply the negative 12 times 7. Negative 12 times 7 is negative 84. And on the other top, what did I multiply the 7 by to get 35? 7 got multiplied by 5 to make the 35. So its top must be 3 times 5, or 15. Okay? So, once again, we are adding and subtracting only the numerator, so we can go ahead and know that the denominator is already going to be 35. Now I have a negative 84 plus 15. Signs are different. You said it. Take the difference. So 84 minus 15 is 69. And then I'm going to have to consider that this difference is going to be negative because 84 is the value with the highest absolute value. It is the furthest away from 0. Negative 69/35 is a fine answer. They have no common factors. Also, if you wanted to, you could say that this is 35 goes into 69 one time. This is going to be negative 1 with a remainder of 34, I guess, since 35 times 2 is 70. 34 over 35. Check my math on that, but I think that works out, right? Negative 1 and 34/35 could be the mixed number. But you have my permission, as long as this cannot be reduced, you have my permission to leave that as an improper fraction. Okay? Are we on to practice examples yet? Yes, we are. So go ahead and pause the video, and I'll do the practice examples. Let's see if we get the same exact answers. All right, great. Let's check it out. Make sure that I didn't make any mistakes, and make sure you let me know if I did. So the first one, the common denominator ends up being 8s. And my final answer was 15/8 or 1 7/8. On number 2, I needed to convert them both to improper fractions. And the final answer was negative 21/10 or negative 2 1/10. On number 3, this is the first one that I need to reduce. The common denominator was 14. And I have 5/14, take away 12/14. And if you remember from last unit, anytime you see subtraction, I change it to adding a negative. And I did that because the number I was subtracting was bigger than the first number. So in this case, I end up with negative 7/14. And yes, it's a great idea to reduce. If you can reduce, you must reduce. All right? Last practice examples. Let's see if we get the same answer on these two. Okay, and lastly, 5/8 plus negative 1/2. A negative 1/2 became negative 4/8 to make the common denominator. And 2 3/4 is 11/4, which I converted to negative 22/8. Now we have the common denominator of 8s, and those added up to negative 21/8. And the mixed number is right there. Also, if you take negative 2 3/7 and minus a quarter, take away a negative quarter, not quarter, 14th, excuse me. That's the same thing as adding 1/14. So I just went ahead and simplified that to a single sign, adding, made the common denominator of 14ths, and it's negative 33/14, which of course is equal to negative 2 and, let me see, 2 and 5/14. Negative 2 and 5/14. All right, so that does it for adding and subtracting fractions for now. We're going to have a couple days of practice with this. So let me know if I made any mistakes or if you have any questions. Don't forget to like and subscribe.